Now I want to explain you one application of the formula nPr. Question is, if np4 equals to 12 times of np2, then what is the value of n? We know that the formula of nPr is what? nPr means factorial n upon factorial n minus r. So here in this problem, the left hand side np4 will be written as factorial n upon factorial n minus 4, because in this formula r is replaced by 4, which is equals to 12 into np2, meaning by factorial n upon factorial n minus 2. Problem, we can factorial n get cancelled. 1 upon factorial n minus 4 is equals to 12 upon what? We can write n minus 2 n minus 3 into factorial n minus 4. If there is a number, suppose 8, we can say 8 into 1 less 9 into 1 less factorial, whatever it is, 8, 7, 6 factorial. If it is 10, 10, 9, 8 factorial. We can write like this. With the help of this, we have cancelled even factorial, this one also. So now we can cross multiply that n minus 2 into n minus 3 is equals to 12. As n is a natural number, so this is one of the natural number, this is again a consecutive lesser natural number, one less than this, is equals to 12, which is what? N minus 2 into n minus 3 is equals to 4 into 3. Ultimately what we are getting, this is n minus 2, n minus 3, this is 4, this is 3. On comparing, we can say n minus 2 is equals to 4. So we can say n is equals to 6. Or what we can say, n minus 3 is 3, so n is equals to 6. Hence at n is equals to 6, this relation np4 is equals to 12 times of np2 will be correct. So this kind of applications are very much possible to ask you in the different problems. Now I am taking one more problem related to the formula of nPr. Prove that 1 into 1p1 plus 2 into 2p2 plus 3 into 3p3 plus dot 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 up to n into npn is equals to n plus 1p n plus 1 minus 1. In order to prove this result, I am taking the left hand side of the problem, this, where we are finding that if it is 1p1, it means that 1 is multiplied. If it is 2p2, 2 is multiplied, 3p3, 3 is multiplied, npn, n is multiplied. So we can write it as r into rpr, and the value of r starts from 1 and goes till which point? N. So the synchronized or the compact form of the LHS is this. Now we have to remember that this is r is equals to 1 to n. This small r can also be written as r plus 1 minus 1 into r p r. So ultimately you know n p n is factorial n. So r p r is factorial r. This r p r will now replaced by factorial r. So this become sigma r is equals to 1 to n r plus 1 minus 1 times of factorial r. When this factorial r multiplied with minus 1 will give us minus of r factorial. So this result is coming r is equals to 1 to n r plus 1 into factorial r minus 1 into factorial r. Now we are writing it r is equals to 1 to n. As we know, it is factorial r and then a number multiplied one more than this. Like if factorial 10 is multiplied by 11, could be written as factorial 11. So here factorial r multiplied by r plus 1 gives us factorial r plus 1 minus factorial r. Now I will expand it. I will get, if I put r is equals to 1. On putting r is equals to 1, the first component will be factorial 2 minus factorial 1 is the second component of this sigma. If I put r is equals to 2, it will be factorial 3 minus factorial 2. If I put 3, I will get 3 plus 1, 4 factorial minus r means 3 factorial plus dot 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 plus. If I put finally n, it will be n plus 1 factorial. This is n plus 1 factorial minus n factorial. After simplification of all these results, factorial 2 will be cancelled by this, 3 by this, 4 by this, n by something. I will tell you, you will be left with only factorial n plus 1 minus factorial 1. Only these two values will left. But factorial n plus 1 is what? N plus 1 p1. As you know, npn is factorial n, rpr is factorial r. So the value n plus 1 p n plus 1 is what? This can be written as factorial n plus 1 minus 1 as it is. So what is this? This is our required result which we would like to show. So this is one of the way of applying or putting the application of the result nPr. Now I am taking one example where some different arrangements will matter. The example is how many words with or without meaning can be made from the letters of the word Monday. Whatever is used in Monday, this is required to use. How many words with or without meaning can be made from the letters of the word Monday? Assuming that no letter repeat if first condition 4 letters are used at a time. I want to tell you, in writing the Monday, first part if I talk, in writing of Monday, how many we have used? Letters are 1, 2, 3, 4, 5, 6. So we have 6 choices, but we want to take 4 at a time. So 6P4, because they are asking the arrangements. How many words with or without meaning can be formed if 4 letters are taken out of the all letters used in writing of Monday. 6P4, which become factorial 6 upon factorial 6 minus 4. This is equals to factorial 6 upon factorial 2. Factorial 6 upon factorial 2 will be 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial. This get cancelled. This become 6 5 is 30. 30 into 12, that is 360. The first part. The second part is all letters are used at a time. So npn all means 6p6, which become factorial 6 upon factorial 6 minus 6, which is equals to factorial 6, and you know factorial 6 means 6 into 5 into 4 into 3 into 2 into 1. This answer 6 5 is 30 and next product is 4 3 is 12, 12 2 is 24, that is 720. And you must even remember few of at least 5 6 values of the factorial. Then the third part, all letters are used, but condition that first is a vowel. In writing of Monday, we have two vowels. So the first letter can be started in two ways. Then we have 6, but out of these 6, one is used in fixing the first position of word required to form. So how many positions are left? 5. So 2 into factorial 5, this become 2 into factorial 5 means 5, 4 is 20, 23 is 60, then 62 is 120. So ultimately it is 120 into 2. Answer is 240. So we must remember that permutation can be linear, permutation can be taken all at a time, permutation may used with some condition that this much number of letters are taken, this much number of items are taken, we should start with this, we should end with this. So some sort of problems are possible in permutation, they will deal with some permutations of the condition. There are some problems where we will use the permutation, but the specific type of problems dealt with the finding of the rank. I am taking an example of that. The letters of the word random, I am talking about random. Whatever total number of arrangements are possible have been made. The letters of the word random are written in all possible order. That is, taking all letters at a time, and we have arranged that as many are possible to write the words which can be formed by taking the letters of the word random, and then arranged in the dictionary. After writing all these, we have arranged like in dictionary in their order of the alphabets. Find the rank of word random. Then we need to find what is the position or at which number this word random will come among all those which have been made. So my first question goes that using in writing of the random, what letters have been used? R, A, N, D, O, and one of the letter is O. So if we want to write all possible, then total number of letters 1, 2, 3, 4, 5, 6, that is factorial 6. 1, 2, 3, 4, 5, 6 factorial 6, that is what? 720 words are possible by making the use of this random. First thing. But if I tell you to arrange in the dictionary, first of all, letters which will start with A come first. So I am writing the order of the letters used in writing the random as per the dictionary condition. This is first is the A, then it is D, then M, N, O, and finally it is R. So as per the dictionary, the order is A, D, M, N, O, R. First I will fix as A. I am looking for all those words which will start with A. So to start with A is being fixed. If A is being fixed, how many letters are left? 1, 2, 3, 4, 5. So this becomes factorial 5, that is equals to 120. Then we begin with D, then factorial 5, again 120. If we come for M, factorial 5, then 120. Then begin with N, factorial 5, then 120. Then begin with O, factorial 5, 120. So number of words which can start with A is factorial 5 because A is fixed, remaining can change their position. So linear permutation for 1, 2, 3, 4, 5 letters is factorial 5, that is 120. Similarly for D, M, N and O. Now we are coming to start with what? D. This is told, then M. Finally we are coming for the R. But we are finding that we want to write what? We want to write random. R-A-N-D-O-M. So R, if I am writing, this R is cancelled because R is the first letter required in writing the random. So then we will go to check that this R is over. We will come after cutting on the top. Then we will take the second letter as A. In writing the random, second is A. Then we will write, after cancelling this, next is D, R-A-D. But third we are writing here D and third is here N. So this can be fixed, and after fixing this we left with 1, 2, 3. So that is factorial 3, answer is coming 6. Now R-A, after D we will go to M. And if M is used, D is made free because we want to write random. If M is used, D is free, then 1, 2, 3. Again we have 3 choices, factorial 3, that is what? 6. Now R-A, after M we are going to write N. If it is N, then what left? 1, 2, 3. But we will take care that N is on the third position here and N is on the third position in the random. So cancelled from both places. Now we left with what? D, because we have to come at top. After cutting we will not go down, we will come at the first. Then we will write D. But D is again matching. So D is cancelled. After cancelling the D, we will go on the letter left is M. So this M, but here it is O. Here it is O. So if it is O and this is M not matching, so O, M is fixed, left is O, this is factorial 1. So answer is coming 1. Now R, A and D. After M we will go to O. O is used here and cancelled, only left is what? M. This become random. Now this is factorial 0. Then answer is what? 1, as I explained you. So total is coming 614. Hence we can say 614 is the rank of random out of 720 arrangements possible for this word. Now one more problem related to the same permutations, that how many words can be formed with the letters of the word university, that vowels remaining together. This is again a question of the conditional permutation. First I want to tell you UNIVERSITY. These are the letters used in writing the word university. So if I tell you that condition is all vowels remain together. First I want to tell you it is U once, then N, then I, then V, then E, then R, then S, then again I, then T and Y. I want to tell you two I's are of same type. So it means that here even we will apply the repeated permutation. What is this repeated permutation? I want to tell you. Suppose I want to arrange A into A into A into B into B. So how many letters are used? 1, 2, 3, 4, 5. If these all are distinct, answer is 5 factorial. But if all these are not distinct as it is, so 3 are repeating, so divide by factorial 3. 2 are repeating, divide by factorial 2. So in case of repeated permutation, what we do? whatever letters or digits are repeating, we have to divide with that factorial in this situation. So here the condition is all the vowels remaining together. So if I take vowels I, 2 times I, these two vowels, then I am taking E. Firstly, I am taking U, this is also. So this become 1, 2, 3, 4, and finally, how many consonants are left? N, V, then R, then S, then T, and then Y. So I just can say that we have 1, 2, 3, 4, 5, 6. These 6 different consonants. And we have how many vowels in the number? We have 4 vowels in the number. But out of these 4, 2 are repeated. And we are bound to take all these vowels together as required in the problem. If this question is free, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then what is the answer of total arrangements? Factorial 10 upon factorial 2 for the 2 identical letters, 2 identical I's. Answer will be this if all are used and 2 I's are of same type. But here 1, 2, 3, 4, 5, 6, these 6 are the different, and all these 4 have to together, means we are taking this entire lot as the one letter. So this becomes factorial 7 upon 2 I's are repeating, factorial 2 into what and why. These 4 letters are together, but together they can interchange their positions. So we can say 4 letters can change their position in how many ways? Factorial 4 ways. So this is the total ways of arranging, and after simplification the answer will be 6060480. So the problems of the permutation can be increased with the level of difficulty, but only after having a read and understanding the condition, we can solve the problem of any level with the help of the formula linear permutation, nPr, factorial 0, and some others.